Hello, welcome to my channel. Maths 2A Chapter 2 Exercise 2B. In the previous video, I have solved the first Roman 1 to 3 problems. Now proceed with the further problems. Fourth question. Given that 1, omega and omega square are the cube roots of unity, then we have to prove that LHS is equals to RHS, that is nothing but 1 by 2 plus omega plus 1 by 1 plus 2 omega is equals to 1 by 1 plus omega. So for this, first we will consider LHS, that is 1 by 2 plus omega plus 1 by 1 plus 2 omega. Now we will take the LCM here. Taking LCM, we can write this as, in the denominator we get 2 plus omega into 1 plus 2 omega, and the numerator will be 1 plus 2 omega plus 2 plus omega. Adding the above terms, that is 1 plus 2, which is 3, and 2 omega plus omega is 3 omega, by, here will multiply 2 1s are 2, similarly 2 2s are 4, so 4 omega plus 1 omega and plus 2 omega square. So we can write this as 3 plus 3 omega by 2 plus 4 omega plus 1 omega is nothing but 5 omega plus 2 omega square. Now we will take 3 common in the numerator, so we will get 3 whole multiplied by 1 plus omega divided by 2 plus 5 omega plus 2 omega square. Now I am splitting this 5, like how we find roots, in that way also you can do. So what you will get here, instead of 5 omega we can write, or simply instead of 5 omega we can write here it as, in the denominator 2 plus 2 omega plus 3 omega plus 2 omega square, that is nothing but 5 omega only. So we are splitting this 5 omega in this way. Then in the denominator, if you look carefully, you can take 2 commons for these 3 values. So what will be left with is 2 into 1 plus omega square, left with 3 omega. Now numerator is same, that is 3 multiplied by 1 plus omega. Denominator, we know that since omega 1 and omega square are the cube roots of unity, 1 plus omega square is equals to 0. So in the denominator we will be left with 3 omega. 3 can be cancelled, left with 1 plus omega by omega. According to this condition, what is 1 plus omega minus omega square? So we will simply substitute minus omega square in the numerator. So we will be left with minus omega. Let this be equation 1. Now you consider the RHS, that is 1 by 1 plus omega. Again from the condition 1 plus omega is equals to minus omega square, but what we will use here is the next condition. When the cube root of unity is 1 omega and omega square, we also know that omega cube is equals to 1. So in this one place we will substitute omega cube. In the denominator we will substitute minus omega square. Understood? Now if I cancel this, we will be left with minus omega again. So 1 is equals to 2, that is LHS is equals to RHS. Hence proved the question which was given to us. In the fourth bit, the next, that is the second question, is 2 minus omega multiplied by 2 minus omega square multiplied by 2 minus omega to the power 10 multiplied by 2 minus omega to the power 11 is equals to 49. We have to prove this. So for this, what we will do is first we will simplify this omega to the power 10 and omega to the power 11. That is, we can write omega to the power 10 as omega to the power 9 into omega. Omega to the power 9 can also be written as omega cube whole cube into omega. Omega cube is nothing but 1, we know this, isn't it? Omega cube is equals to 1. So we will substitute as 1 cube. Therefore we can substitute omega to the power 10 as omega. In the similar way, if we see that is omega to the power 11. It can be written as omega to the power 10 into omega. Omega to the power 10 is omega. So omega into omega, omega square. Therefore omega to the power 11 is omega square. We can substitute this in place of omega to the power 11. So first we'll consider to solve this the LHS. That is 2 minus omega square, 2 minus omega to the power 10, 2 minus omega to the power 11. Then we will substitute omega to the power 10 and omega to the power 11 as omega and omega square. I have showed you how we can substitute it. Now omega 2 minus omega and 2 minus omega is common, and 2 minus omega square is also 2 times here. So we will consider this to be whole square in this way. 2 minus omega into 2 minus omega is 2 minus omega whole square, and 2 minus omega square into 2 minus omega square is 2 minus omega whole square. So we are considering 2 minus omega into 2 minus omega square whole square, which is same only, right? Now we'll multiply the terms inside the bracket. We'll get 2 into 2 is 4 minus 2 omega square minus 2 omega, and this will be minus omega cube whole square. Now omega cube is equals to 1, right? We'll substitute that. So 4. Here we can take minus 2 common. We are taking minus 2 common, left with omega square plus omega, substituting omega cube as 1. Okay, so we'll be left with 4 minus 1 is 3. Okay, I'll write in this way: 4 minus 1 minus 2. Now we know that 1 plus omega square is equals to 0. Now from this, what is the value of is equals to 0? Omega plus omega square value is minus 1 from this. Am I right? So we'll substitute this value of omega plus omega square here. So we will get it as, wait, here minus into minus is plus, so we'll get here plus omega cube. So it's plus 1 and here it is also plus 1, so we'll be left with 5 plus 2 whole square, yeah, which is equals to 7 square, which is 49. Therefore 2 minus omega square, 2 minus omega to the power 10, 2 minus omega to the power 11 is equals to 49. Proved. Okay, this is the third question in which we have to prove this LHS is equals to RHS. So first we'll multiply the first and second term, then the value which we'll get from that will multiply the third term. Let's see what we'll get. So here I'm first writing consider LHS. This is the LHS we have here. Now I'll multiply this with this term. So what I'll get, x square, x into y omega, x y omega, then x into z omega square, that is x z omega square, plus, now with y we'll multiply these three values. So xy will get here, y into x is xy, then y into y omega is y square omega, y into z omega square is y z omega square. Okay, then with z we are multiplying, so zx plus zy omega plus z square omega square, multiply by this term. Okay, so what we get is, now we'll take x square, y square and z square terms separately first. So x square plus, what is y square term here? Y square omega, and here we have z square omega square. Now what I am going to do is, I will take xy common here. If I take xy common, what I will be left with is 1 plus omega, right? That is xy and xy omega. Xy common will be left with 1 plus omega, or omega plus 1 also you can write. Then I will take yz common. If I take yz common, I'll be left with omega square and omega. So omega plus omega square. Then I'll take zx common, with which I'll be left with omega square, that is this term, and 1. So that is 1 plus omega square, or omega square plus 1, which we can write. This is completely multiplied by x plus y omega square plus z omega now. Okay, here we know that, or since I can say that 1 plus omega square is equals to 0, therefore 1 plus omega is equals to minus omega square. Similarly, 1 plus omega square is equals to minus omega, and omega plus omega square is equals to minus 1. And now let us substitute these values in these three places. So what we'll get? X plus y square omega plus z square omega square, okay, plus xy into what it is, minus omega square, plus yz into minus 1 plus zx into minus omega, right? This is completely again multiplied by x plus y omega square plus z omega. I will multiply these terms. So x plus y square omega plus z square omega square minus xy omega square, you will get here, then minus yz, you will be left with minus zx omega, right? This is multiplied by x plus y omega square plus z omega. So after multiplying these all terms, I'll get this. Let me explain you. That is, I have multiplied this term with this term. Okay, so what I have did here is x square into x, which is x cube. Okay, then y square omega into x y square omega, z square omega square into x z square omega square. Similarly, minus xy omega square into x is minus x square omega square, and with minus xyz, I'll get minus x square z omega, that is minus zx square omega. So with x I have multiplied all these terms first, then all these terms I have multiplied with y omega square, that is x square into y omega square, x square y omega square, y square omega into y omega square is y cube omega cube, z square omega square into y omega square, z square omega square y omega square, that is nothing but z square y omega to the power 4, right? This is nothing but z square y omega to the power 4. Okay, then minus xy omega square into y omega square, this is minus xy square omega to the power 4. Then minus yz into y omega square minus y square z omega square, then minus zxy into y omega square is xyz omega cube. Then similarly with z and z omega, I have multiplied all these terms and I have got this. Okay, now I'll cancel the similar terms with the opposite signs. I have here some of those terms like x y square omega, and here x y square omega 4. So for this, first what I'll do is I'll again write the cube terms first together, that is x cube and y cube omega cube and z cube omega cube. Then I'll write xyz terms. Okay, that is minus xyz from here, then from here minus zyx omega cube, then from here minus xyz omega cube. Okay, then the leftover terms I will write, that is first with xy square omega. I will write that is xy square omega is first term. Then similarly we have minus xy square omega 4. So I'll write here minus xy square omega 4. Then I'll consider xz square omega square plus xz square omega square. So where is xz square term? One more term you will definitely get xz square. Here it is xz square omega square minus xz square omega square. Here only we can cancel this, right? Isn't it? Opposite signs these both have. Then what is the next term? X square y. So minus x square y omega square. Here we have x square y here. X square y omega square, the plus sign, plus x square y omega square. Now this and this again can be cancelled, isn't it? I'm writing in this way to make you understand. Then the next term is minus z x square omega. So what is one more zx square term? This is zx square omega. Again these both have the opposite signs. So again we can cancel this. So I'm cancelling this here. Then the next term we are left with, this we have considered first only. Then this we haven't considered yet. That is yz square. That is, so we'll consider that also. We'll get it as plus z square y omega 4 and also z square y minus this term minus z square y omega. Then the next one is y square z. This we have considered already, this we haven't considered yet. That is minus y square z omega square, and one more term we have this. Both terms we can cancel. Okay, then left all terms are considered here only. Before only I have considered, and all this will be cancelled because omega 4. I'm writing here, since omega 4 can be written as, okay, omega cube into omega, right? Omega cube is what? 1 into omega, which is omega. So omega to the power 4 can be substituted as omega. So I'm substituting omega to the power 4 and omega, and if I write, what I get is, so I have substituted here omega to the power 4 as omega, and omega cube also the value is 1. So we'll substitute that also. Here also we have substituted omega to the power cube, that is 1. So we will finally be left with x cube plus y cube plus z cube minus xyz minus xyz minus xyz. These terms will get cancelled here. We will be left with x cube plus y cube plus z cube minus 3xyz, which is the RHS. Therefore LHS is equals to RHS is proved. So in this way you can solve this problem. Go through this problem thoroughly once, because here we have to multiply many terms. Okay, let's move to the next question, that is the fifth question. You are given that 1 omega and the omega square, the cube roots of unity, and we have to prove minus omega and minus omega square are roots of the equation given to us. That is, the given equation is z square minus z plus 1 is equals to 0. We have to prove that minus omega and minus omega square are the roots of this equation. So for this we will consider z as minus omega first. Okay, if I substitute minus omega, I have to substitute here. What will get? Minus omega whole square minus of minus omega plus 1 is equals to 0, which is equals to omega square plus omega plus 1 is equals to 0. We know that when 1 omega and omega square are the cube roots of unity, then 1 plus omega square is equals to 0. Right? Therefore, we have, when we substitute minus omega z, we have proved that these are the roots. Then similar way, we will do we will again substitute z as the next thing which is given to us, minus omega square. So if we substitute minus omega square here, what we'll get here? Minus omega square whole square minus omega square plus 1 is equals to 0, which will be equals to omega to the power 4 plus omega square plus 1. Omega to the power 4 is nothing but omega cube into omega, which is 1 into omega equals to omega only. So we will be left with 1 plus omega square plus omega equals to 0. Therefore, from these two equations, when we substitute it, we can say that minus omega and minus omega square are the roots of the given equation. Thanks for watching the video. Do like, share, comment and subscribe. Don't forget to hit the bell icon.